Okay, interference was observed in interference chamber where air is present. Now the chamber is evacuated, and if the same light is used, a careful observer will see what. So we have to check what happens to the interference on replacing air with vacuum. So the size of constructive interference, the size of the bands, the interference band, is x equals to lambda capital D by small d. Now this lambda depends on the medium. So the difference between air and vacuum is the wavelength of light in air is wavelength of light in vacuum divided by refractive index of air. So wavelength of light in air is slightly lesser than wavelength of light in vacuum. So if we take this to be the size of interference fringes in air, so this is wavelength in air. The wavelength in vacuum, the size in vacuum would be wavelength in vacuum d by d. So we can see there is a direct relation between them. So if we use vacuum, for vacuums we have slightly bigger wavelengths. So let's divide both of these. So the size in vacuum, the size of fringes in vacuum divided by the size of fringes in air is wavelength of light in vacuum is to wavelength of light in air, and that ratio from here we can see is refractive index of air. So the pattern, the size of the fringes become n times the size of the fringes in air. So the entire pattern becomes wider. Okay, so interference with larger width should be the correct option. So D is the correct option. Okay.